Hello, and welcome to TI's Precision Labs, an online video curriculum for engineers. This Precision Lab video will provide an introduction to isolation certification and safety standards. This video will answer the following questions about the relationship between industry safety standards and isolation component specifications. What are functional, basic, and reinforced isolation ratings? Who defines safety standards? What are system versus component level certifications? How are devices tested for high voltage safety? And how do I know my device meets industry standards? Certification and safety standards are a critical part of designing isolation for high voltage systems, and understanding the difference between component and system level standards, isolation ratings, and isolation specifications will help in selecting the best isolation solution for your needs. In previous videos, we've introduced the role of isolation in a system as essential for high voltage systems, and that isolation is used to prevent DC and unwanted AC currents from flowing between two parts of a system. Semiconductor ICs used for isolation are called isolators and are used in electrical systems for both function and safety. The way that an isolator is used determines the required insulation level mandated in order to meet safety standards for an end equipment to be sold in the market. Ensuring that isolation safety is measured in a consistent and reliable way is achieved through the use of standards and certifications. International and regional standards bodies develop standards to ensure uniform specification and testing of components and systems, including isolator components and isolated systems. What are functional, basic, and reinforced isolation ratings? When an isolator is used to enable a system to function properly, but not necessarily to serve as a barrier against electrical shock, it is called functional isolation. An example of this may be PCB material between traces on a board. For systems where hazardous voltages are present, industry standard isolation ratings become more relevant and are described with the terms single isolation, basic isolation, double isolation, and reinforced isolation. Basic and single isolation describes isolation that provides sufficient protection against electrical shock as long as the insulation barrier is intact. In the presence of high voltage, safety regulations require basic isolation to be supplemented with a secondary isolation barrier for redundancy to provide shock protection in the event that the first barrier fails. This is called double isolation. As an alternative to using two physical isolation barriers, reinforced isolation is used in high voltage systems. Reinforced isolation might look like a single level of isolation, but has the high voltage electrical strength, reliability, and shock protection equivalent to two levels of basic isolation. Determining which isolation rating is required for your solution requires matching component ratings to industry-approved safety standards. There are several organizations who define national and international safety standards for both isolation in equipment and components. The IEC publishes international standards and works with multiple organizations to prepare worldwide industry standards for electrical and electronics equipment. Often, region-specific standards will be adopted by the IEC for worldwide use. For example, VDE is a German-based association that defines electrical, electronic, and information technologies and standards. The primary standards for reinforced isolation ratings in digital isolator components is defined by VDE and adopted by the IEC as a global standard. Organizations that develop and publish safety-related standards include the IEC, which prepares international standards for electronic equipment, VDE, which defines standards for electronics and information technology and represents the leading standards for digital isolators, UL, which is widely known for equipment standard development, testing, and certification, and CSA, which is the Canadian Standards Development and Certification Body accredited by the SEC, also known as the Standard Council of Canada, and the CQC, or China Quality Certification Center, which manages certification and testing of equipment to SAC, or the Standardization Administration of China standards. Some of these standards organizations provide testing services to obtain certificates for components or equipment, while others require the use of independent test agencies to certify components or electronics to obtain certifications. Determining which certification is needed will depend on the region where the end system will be sold, and it is important to ensure that both the required end equipment and the component level standards are met for the region of sale. Isolation standards are different for component and system level certifications. Component safety standards are required to be met by the manufacturer of the isolation device, while end equipment standards are required for the user of the isolation component. In order to be considered reinforced, All isolator components, regardless of technology, must meet component-specific standards that apply to them, as shown here. This means optical isolators must provide certification to UL 1577 and IEC 60747-5-5, while digital isolators must meet VDE 0884-11. To serve a worldwide market, component suppliers must work to meet as many required certifications as possible, including keeping the most recent certifications up to date. As of December 2019, all digital isolators are required to meet the new VDE 0884-11 test conditions in order to maintain IEC reinforced ratings. Often end equipment designers will choose components that are pre-certified to the requirements of the end equipment standard, in addition to the individual component standards, as a means of reducing obstacles in system-level certification. For example, while IEC ESD is not a required component-level certification test, many vendors provide IEC ESD test data to provide added confidence for the end user about performance expectations during certification testing. The IEC provides standards for end equipment providers, and some of the most common system-level standards that required isolation are showed here. System providers must meet both functional and regional system-level certifications to serve an end market, and those certifications include both electrical voltage testing, environmental testing, physical attributes such as creepage and clearance. You can learn more about creepage and clearance in the TI Precision Lab titled, What is Creepage and Clearance? How are devices tested and certified for high voltage safety? With so many isolation certification standards, it can be challenging to compare isolation performance between two component technologies. Before making an isolated component selection, it is important to understand the differences in key tests required to retain a reinforced rating within each standard by technology. This table provides a brief comparison between technology types and required testing to achieve reinforced rating with the relevant standards bodies. There are 6 key areas highlighted to demonstrate differences between these standards: maximum surge voltage, partial discharge test, working voltage, minimum rated lifetime, failure rate over lifetime, and allowed isolation materials. We will briefly review these tests and definitions and what they mean to the performance of the isolator. Surge voltage describes the performance of an isolation barrier following a repeated series of short-duration high-voltage pulses. The surge waveform is defined as an industry standard test with timing characteristics specified by IEC 61000-4-5. The test is carried out by placing the device on a test board and shorting all pins on both sides of the isolation barrier. Using a high-voltage pulse generator connected to one side of the isolation barrier with a return connected to the other side of the barrier, 10 pulses are applied to the lowest level, and upon passing, the level is increased until the maximum specified surge voltage is reached, or the isolation barrier fails. To receive a reinforced certification from VDE for digital isolators, the surge voltage tested must exceed the specified surge voltage on the datasheet by 1.6 times, as well as pass a minimum 10 kV surge test. For optical isolators, the minimum 10 kV survival is the only requirement, which is determined by the large distance through the insulator, or DTI, of the optocoupler. Digital isolators, or thin film insulator technology, is notably different than optocouplers. Therefore, standards bodies require different performance data to prove safety for a reinforced rating. For digital isolators, tested surge data is required, whereas for optocouplers, a minimum distance specification is most relevant. The combination of distance and the quality of the insulating material play a direct role in whether or not an isolator will survive the surge test. The insulation barrier for an optocoupler is so large that a low-quality dielectric can be used and still survive this test from air to epoxy. Because digital isolators use high-quality dielectrics that are significantly smaller, in the range of tens of micrometers instead of hundreds of micrometers, the high-quality insulation material itself enables for higher surge ratings in smaller packages than the classic optocoupler technology. As a result, DTI specifications for digital isolators and industry standards enable smaller package solutions for component-level isolation. Partial discharge testing is a method of measuring for defects within a dielectric barrier by using charge distribution to identify potential defects. The partial discharge test is designed to identify the presence of defects or voids within the barrier by applying a high voltage that will build up energy across any existing voids. This buildup causes a redistribution of charge within the barrier that is known as a partial discharge, which can then be measured as leakage current. Because the dielectric for an optocoupler can vary from air to epoxy and is achieved in product assembly, the partial discharge test is one way to identify defects and voids within the isolation barrier or mold compound and to screen out potentially defective materials. Both digital isolators and optocouplers are tested using the standard test called the partial discharge test using method B1 as shown here. This test profile is a production screen required by both IEC and VDE standards for certification. However, the partial discharge method does not fully represent the test required to measure the lifetime of a modern digital isolator. This is because in modern digital isolators, the dielectric is deposited in a tightly controlled wafer manufacturing environment or certified clean room. To truly test the isolation barrier for a modern digital isolator, a test that identifies defects beyond the mold compound is needed. Maximum working voltage quantifies the ability of an isolator to handle high voltage across its barrier on a continuous data basis throughout its lifetime. Working voltage and lifetime for digital isolators are determined by using TDDB, or time-dependent dielectric breakdown analysis. TDDB data for digital isolators is an industry standard method of measuring dielectric breakdown over time by applying a constant energy field to a dielectric and then measuring the point of breakdown. Because the relationship between time and dielectric breakdown for semiconductor materials is predictable and well understood, this method allows for accurate prediction of lifetime for the material under various applied stresses. You can see from the curve shown here that at an applied voltage of 1.5 kV, the anticipated lifetime of the barrier is expected to be beyond 40 years. Most use cases will not approach 1500 volts constantly applied voltage, but insights into the anticipated performance of the barrier provide confidence for high voltage safety uses. Guard banding is used to provide the highest level of confidence for any operating conditions of working voltage within the safe operating area, and these can expect a failure rate over the lifetime of the device of less than 1 part per million. While optocouplers do use the partial discharge method to determine working voltage, they do not specify anticipated lifetime or failure rate over lifetime, as these are not currently requirements of the component standard. A more detailed explanation of TDDB data methods for isolation and high voltage testing are explained in detail in the TI white paper enabling high voltage signal isolation quality and reliability, and in the TI video series, What is High Voltage Reliability? This concludes the Precision Labs video, What are Isolation Certifications and Standards? We've given a brief introduction to certification standards and discussed that functional, basic, and reinforced isolation ratings are industry standard terms used to describe levels of voltage isolation for performance and safety. That industry safety standards are determined by industry committees and standards bodies, which are comprised of industry experts who provide certifications of performance. That achieving system level and component level certification requires proof of performance in defined test conditions and in approved test facilities. That high voltage performance levels are defined by specific industry standards tests and can include surge, working voltage, and insulation requirements. And lastly, that devices meet industry standards are specifically identified through certification, which should be available on the vendor website. Thank you for watching. Please continue watching to take the online quiz. True or false? Compliance with device level certifications are optional if designing an end equipment because the IEC certifications are all that is required. False. While IEC and equipment level certifications will determine the needed system level certification, end equipments also have specific isolation component level certifications that must be met. Additionally, regional and equipment certification requirements must be taken into account and met in order to produce a product that can be sold into multiple markets. It's important to ensure that component level safety certifications are current and meet the IEC guidelines for isolation components. Why do optocouplers require higher DTI specifications than modern digital isolators? Distance through insulation, or DTI, is a specification that is used to limit the risk of surge overvoltage. Modern digital isolators offer the highest dielectric strength insulation materials over optocouplers and are therefore able to provide higher surge voltage protection in smaller distances. Based on the TDDB curve below, if working voltage for my design is at 500 volts RMS, what is the anticipated lifetime of the digital isolator that I'm using? At 500 volts RMS of working voltage, lifetime of the digital isolation barrier would exceed 100 years. This concludes the Precision Labs video, What are Isolation Certifications and Standards? You can browse more isolation topics and resources at www.ti.com/isolation.